All right, here we go. Solving absolute value equations in 2 steps now. So if we take a look at problem number 1, the absolute value of 3x plus 5 is equal to 14. First things first, the bars are isolated. Is this problem solvable? Yeah, because it's asking, how do I get a distance of 14? Well, I take the inside, whatever it may be, and notice that I'm taking the exact same expression and making 2 separate equations out of it. In other words, I want 3x plus 5 to go forwards 14 steps, or I want 3x plus 5 to go 14 steps backwards. So 3x plus 5 can also equal negative 14. Notice that I'm incorporating both equations, and I'm trying to get the inside to be 14 or negative 14. Well, I'm going to start with the right side since I'm a positive person. Let's start with 3x plus 5 equals 14. So I'm going to subtract 5 from both sides. And that gets me 3x is equal to 14 minus 5, which is 9. Now I've got 3x is equal to 9, and I'm going to undo that times 3 layer by dividing both sides by 3. So now I've got x equals 9 divided by 3, or 3. But is this problem completely solved? No, the directions say find the solution set, not solve for x. So if you only put one solution down, you will get half credit. So let's take a look at the other side. 3x plus 5 is equal to 14. So I'm going to subtract 5 from both sides, same thing. So 3x plus 5 is equal to negative 14. Now I'm going to subtract 5 from both sides. That leaves me with 3x equals negative 14 minus 5. We're going further underground. We're going down to level 19 underground. So that's negative 19. So now I've got 3x is equal to negative 19. Now I'm going to divide both sides by 3. You plug it in the calculator, you get negative 19 divided by 3 is a decimal. So I'm okay with you guys leaving it as negative 19 thirds. Or if you want to express this as a decimal, you can write this as, well, 3 goes into 19 6 times with 1/3 remaining. So negative 19 divided by 3 is negative 6.333333333333333333. You get the idea, but notice it's a repeating decimal. So I just put negative 6.3 with a hat to indicate that it's repeating the 3. So negative 6.3 with a hat on the 3. I want one of these two. I want negative 19 over 3 or negative 6.3 repeating. Now, I want both distinct solutions, the left and the right. Okay? All right. This one's going to have 2 fractions. So I've got 6x plus 1 is equal to 4. My mistake. The absolute value of 6x plus 1 is equal to 4. Is this problem solvable? Yes. So what I'm going to do is I'm going to take the inside and split it into both cases. So either 6x plus 1 is equal to positive 4, or 6x plus 1 is equal to negative 4, because I have to account for both forwards and backwards. So now I'm going to solve for x on both sides. I'm going to start with the positive side since I'm a positive person. So let's take a look at this. How do I undo the layers of 6x plus 1 is equal to 4? Well, I'm going to isolate the outer layer by subtracting 1 from both sides. sorry, I'm going to isolate 6x by subtracting 1 on both sides. So 6x is equal to 4 minus 1, which is 3. 6x is equal to 3. Now I'm going to divide both sides of the equation by 6. And that leaves me with 3 divided by 6. Remember, 6 is going into 3, not the other way around. 6 cannot go into 3, so I'm going to leave that as a fraction. But notice that I want it as a reduced fraction, 3/6. So you can tell me the decimal equivalent. Well, that's going to be 0.5. I'm okay with that. But if you're going to leave it as a fraction, make sure that the fraction is completely reduced. I can divide the top and bottom by 3 and make it 1/2. So either way, that is one of the solutions. These two numbers are the exact same, 0.5 and 1/2. However, I want to solve for the other side. I'm actually going to get a pen after this problem because I noticed the pencil is not dark enough. So for the sake of this problem, I'm going to finish this in pencil. So let's subtract 1 from both sides. That cancels out, leaving me with 6x is equal to -4 minus 1, which is -5. And now I'm going to divide both sides of the equation by 6, leaving me with, I'm okay with this because it's a reduced fraction. A negative divided by a positive is a negative, so that's a -5/6. But if you are so decimal inclined, I can write -5/6 as -0.8333333. So remember, it's a negative. But the 3 is repeating, so I'm going to put a hat on the 3, not the 83. Either way, you can even mix and match if you want. If you like, I've seen students go -5/6 or 0.5. I'm okay with that. If that's what you prefer, be my guest. Okay, moving on to problem number 3. See if you can do, oh, this one has a negative in there, but see if you can do this one independently. I'm going to get a black pen this time. Well, once again, what makes me nervous is there's a negative in front, but there's no coefficient. So what can I automatically put? I'm going to put this imaginary 1. It's just floating right there. But first things first, is this problem solvable? Yes, the absolute value is isolated. The bars are isolated, and it equals a positive output. So I'm going to split this into 2 equations. So I'm going to make life easy by making this -1x. So now I've got -1x, that's much better. -1x plus 8 is equal to 17. And I've got -1x plus 8 is equal to -17. I'm going to solve both equations. So let's solve for the right side since I'm a positive person. -1x plus 8 is equal to +17. So I'm going to subtract 8 from both sides. That cancels out the 8's, leaving me with -1x is equal to 17 minus 8. 17 minus 8 is going to give me +9. I'm going to divide both sides of the equation by -1 because I want +1x on both on the coefficient. So that gets me 9 divided by -1. The -1's cancel out, leaving me with x is equal to -9. But that's not the only solution. I'm going to do the same thing on the left side. -1x plus 8 is equal to -17. So now I'm going to subtract 8 from both sides. So now that that cancels out, I'm left with negative 1x is equal to negative 25. And now I'm going to divide both sides of the equation by negative 1. And now negative divided by negative is positive. So negative 25 divided by negative 1 is positive 25. So my two solutions are that x can be 25 or x can be negative 9. Note, take the inside, split it into two equations, account for forwards and backwards. Okay. Number 4. So it's a little bit backwards, but once again, this makes me a little bit nervous. Well, first off, is this problem solvable? Yeah, I've got the absolute value. It equals a positive output, so it is solvable. I'm going to split this up into two separate equations. Notice I'm going to take the entire 3 minus x and split it into two equations. So I'm going to take this entirely. I'm going to account for 3 minus x is equal to 20. Or 3 minus x is equal to negative 20. I'm going to account for both cases. But since there's no coefficient in front of the x, I can make my life easier by putting this imaginary 1. So it's actually going to be negative 1x. So 3 minus 1x is equal to 20. Now I'm going to solve for x. If it makes your anxiety a little bit calmer by switching the problem around, if it just calms you down a little bit, you can write this problem as negative 1x plus 3. But either way, I'm going to undo that plus 3 layer by minusing 3 on both sides. So negative 1x is equal to 20 minus 3, or 17. I've got negative 1x is equal to 17, so I need to divide both sides of the equation by negative 1. And now x is equal to 17 divided by negative 1, which is going to be a positive divided by a negative is a negative 17. So x equals negative 17 is one of the solutions. Moving on to the other side, if I do 3 minus 1x is equal to negative 20, and I subtract 3 from both sides, that gets me negative 1x is equal to negative 20 minus 3, which should be negative 23. Now I'm going to divide both sides of the equation by negative 1. So negative 23 divided by negative 1 is going to be positive 23. So I've got two solutions. Either x can equal 23 or x can equal negative 17. I forgot to plug in for the previous problem, so I'm going to do it with this one. Let's say I plug in 3 minus 23. If I plug in 23 in for x, 3 minus 23 would be negative 20. But the absolute value of negative 20 is 20, which is what we wanted all along. So that checks out. Now I'm going to plug in the other solution. X equals negative 17. Remember, even if there's a negative in front of x, I'm plugging in place of the x. So that's going to be 3 minus blank. So what goes in the blank this time? Negative 17. So that'd be 3 minus negative 17, or the double negatives. I'm not teaching on an iPad right now. I am teaching on an iPad right now. 3 plus 17. 3 plus 17 would be 20, and the absolute value of 20 is 20. Okay, so that's how you can check your work, even with the mixed numbers, even with the decimals. Okay. Number 5. Negative 2x minus 5 in the absolute value bars is equal to 19. See if you can do this problem independently. Okay, you can use the pause button. So once again, I take what's inside. The problem is solvable because the output is positive. So now I've got negative 2x minus 5 is equal to positive 19 or negative 19. So I account for both cases. So let's say I start with the right side since I'm a positive person. I'm sorry, I want my black pen. There we go. So I got negative 2x minus 5 is equal to positive 19. I'm going to undo the layers of x by adding 5 to both sides. So that gets me negative 2x is equal to 19 plus 5 is 24. And now I've got negative 2x isolated, so I'm going to divide both sides of the equation by negative 2. So now I've got x is equal to 24 divided by negative 2, which should be negative 12. That's one of the solutions. I don't want half credit, I want full credit. So let's say I take a look at this problem on the left. The same expression, but this time negative 2x minus 5 is equal to negative 19. How do I undo the layers of x for this particular problem? I'm going to add 5 to both sides, same old, cancel it out, and I'm going to get negative 2x equals negative 14. And now, like the previous problem, I'm going to divide both sides of the equation by negative 2. And that gets me negative divided by negative, that's going to be a positive. So x is equal to 14 divided by 2, which is positive 7. So I'm going to, since they're both whole numbers, I'm going to plug them back in just to show you. Let's say I start with the left side. What is negative 2 times positive 7? Negative 14. So that's negative 2 times 7, which is negative 14. Now, negative 14 minus 5, negative 14 minus 5 is negative 19. Therefore, the absolute value of negative 19 is in fact 19. That's what we wanted. But wait, there's another way of getting that. Let's say I plug in x equals negative 12. Negative 2 times negative 12 will be positive 24. Positive 24 minus 5 is positive 19. And yet the absolute value of positive 19 is also 19. There are two ways of getting the exact same output, and that's what the directions say. That's why the directions say find the solution set, not solve for x. Okay? See if you can do problem number 6 on your own. Well, let's look at the absolute value bars. Is this problem solvable? No, I'm not going to waste my time. The absolute value bars equal negative 25. There's no way. Absolute value bars cannot generate a negative output. So as nice as this problem looks on the inside, I really don't care. This has no solution. There's no way for an absolute value to generate a distance of negative 25. I can't gain gasoline by going in reverse in my car. I'm still going a distance. So if the absolute value bars are equal to a negative output, there's just no solution. Okay, 2 more, and then we'll call it a day. See if you can do this problem on your own. Sorry, I'll give you these two last. 7 and 8. See if you can do these two problems independently. Okay, I'm going to take a look at number 7. The absolute value of 3x minus 4 is equal to 25. Is this problem solvable? Yes. Since the output is positive, I'm going to create 2 equations. One to represent forwards, one to represent backwards. So I'm going to take a look at this problem, copy the exact same expression, negative 3x minus 4 and negative 3x minus 4. I'm going to go forwards 25 steps. I'm going to go backwards 25 steps, but I'm still going 25 steps. Big or in the middle. So now I'm going to solve for both values of x that make this statement true. Let's start with the right side since I'm a positive person. So, how do I undo the layers of x to solve negative 3x minus 4 is equal to 25? I'm going to add both sides by 4. So what that does is it cancels out negative 4, leaving me with negative 3x is equal to 29. Now, in order to isolate x, I'm going to divide both sides of the equation by negative 3. So therefore, x is isolated, well, 29 divided by negative 3, that's going to get me a decimal. But if you want to leave it as an improper fraction, go ahead, negative 29 over 3. Well, if you really like your decimals, fine. 3 goes into 29, well, 3 goes into 27 9 times. And since there's a remainder of 2, that's going to be 0.666666666666666, and your calculator might round out the last digit to be 7, but really it's just a repeating 6. So negative 9.666666666666666 repeating. I'm just going to put a little hat on the 6. Remember, these are 2 of the exact same number. So that even though I've boxed 2 values of x, they're the same number, you just pick one that you like, the decimal or the fraction. Now, I'm going to look at the other equation. Negative 3x minus 4 is equal to negative 25, and I'm going to do the same exact thing to solve for x. I'm going to undo the outer layer by adding 4 to both sides. So that gets me negative 3x is equal to negative 25 plus 4, which is going to be negative 21. And now I'm going to divide both sides of the equation by negative 3. So now I've got x is equal to negative 21 divided by negative 3. Negative divided by negative is positive, so 21 divided by 3 is positive 7. Remember, there are 2 distinct solutions I'm looking for if the problem is solvable. Either x is equal to 7 or negative 29 thirds. X is equal to 7 or negative 9.6 repeating. The same exact answer solution set. All right. Number 8, 5 minus 9x in the absolute value bars is equal to negative 50. Is this problem solvable? The answer is the absolute value cannot generate a negative output. So if the absolute value equals a negative number, you know that this problem cannot be solved. X has no solution. Do not waste your time. Okay. All right. That concludes it for today. I will see you tomorrow.